Hi everyone. Today I'd like to introduce a tool called VDJcraft. It's an integrated pipeline for analyzing VDJ recombination using long-read transcriptome data. I'll briefly walk through the workflow of VDJcraft along with its applications. VDJcraft takes long-read transcriptome sequences as input and applies a two-pass alignment strategies to accurately capture full-length VDJ gene segments. In the first pass, reads are aligned to a reference genome, such as gene code, using Minimap2. This is followed by a second step of local realignment and annotation against the IMGT database. To improve D-gene detection, we implemented a customized alignment module that enhances both sensitivity and positional accuracy. In addition, VDJcraft includes an error correction step, which sequences are corrected toward the dominant subclass using a consensus-based approach to reduce sequencing errors. We evaluated VDJcraft using simulation datasets and compared its performance with Trust4 and LIM analyzer. The results shows improved accuracy in both gene segments identification and VDJ recombination detection. We then apply VDJcraft to real datasets from HGSVC, where it showed better performance than existing tools such as Trust4, while also detect 31 novel events potentially caused by somatic hypermutations. Finally, we applied VDJcraft to COVID-19 patient samples to investigate immune responses during recovery. We observed distinct patterns of V gene enrichment over time. For example, IGHV-1/2 was enriched at day 1 and day 4, but showed a marked decrease by day 8 and day 13. Interestingly, day 4 also exhibited a broader diversity of IGHV gene usage. Results also showed the dynamic changes in clonal types of VDJ recombination throughout the recovery process. We also detected a prominent class switch events with IgG2 showed peak enrichment at day 4, along with the emergence of specific functional CDR3 motifs during the recovery. Okay, so next, I'll walk through how to install VDJcraft and briefly introduce its key functions. Here is the GitHub page. Some detailed information is available on the GitHub page, so feel free to explore it for more comprehensive guidance. When you open this GitHub page, you'll find the step-by-step installation instructions. If you are using the Linux system, start by opening your terminal. Okay, so first to make sure that your Conda is installed on your system, you can go to Conda website or Miniconda website. It's very easy to follow and install Conda environment. Then on your terminal, first you need to using the git clone to download the VDJcraft. Okay, so VDJcraft is in your current folder. You can open the VDJcraft. Then here is the step-by-step installation of the VDJcraft. Let's create an environment first. It can take a little moment to create the environment. So once it's done, we can just activate the environment. Then there are a few dependency package you will need to install first. Okay, so also install Minimap2. Yes. Okay, once all the dependency package are installed, we can there The tools are in the package already, so you can make the VDJcraft executable. Then you can run its help. Okay, so there are the functions of the VDJcraft. There are a test FASTQ files that you can try to see if the installation is successful. The test command line is also available on the GitHub page. So you need to download the reference files. For example, here is HG38 from Gcode to your directory. And the import would be the test FASTQ, and the output folder is test. Your output file name is VDJcraft. Then let's just run it. Okay, so once it's finished, the output files are in the test. We can open it. Okay, so this is the output directory and the output files. You'll see several files generated by the pipeline. The main output is the VDJcraft report. This file is a report of a list of VDJ applications from long-read transcriptome data, including let's just open this file, and you'll see the count of each clonal types and the corresponding V gene, D gene, G gene, C gene, as well as CDR sequences and amino acid sequences. Okay, there are other files such as VDJcraft ident is a report of VDGC gene identifications of long reads. And there are also CDR3s, which is each read corresponding CDR sequences and as well as CDR1, CDR2, CDR and other intermediate files that you can choose to use or not. Okay, VDJcraft also provides several optional functions to enhance analysis. For example, here you can use -m to enter the cutoff of matching rate for the somatic hypermutation, and -n is to get the novel events due to the somatic hypermutation, and the -s is to adjust the score that you want to use. The default is 300, and adjust the percentage identification percentage. You can also use -t to use T2T as human reference genome and HG37 as reference. Also you can use apply to mouse if you have the long reads mouse samples that you need to analyze. If you have ONT data, you can use -ONT to use as input. Okay, if you have a BAM file, you can just directly don't need to do the alignment step. You can just directly go to the downstream analysis. Okay, so this is a brief overview of VDJcraft. Please feel free to visit our GitHub page and share any questions and comments or feedbacks. We'd be happy to discuss further. We hope this tool is helpful for your research. Thank you so much for your attention.